Hi all. In this lesson, we're going to actually use the power of a computer to solve calculus for us. So over time, we've sort of advanced our understanding, right? So when we started, we gained an appreciation that it was possible to kind of take a shape and split it apart, and it made it easier to measure. Now, eventually, we sort of made these intuitive and visual descriptions of what was possible, and then we learned to actually use the notation of calculus to say integrate 2 pi r dr from 0 to r. Now the last step is to actually work that out. And at first we had to kind of measure the area. We just say, well, okay, here's what we want to do. Let's get out the formula for area of a triangle and start cranking through it. But we've actually made a description which is so specific that a computer can actually do the steps for us. And it can apply the rules and work it out. So Wolfram Alpha is actually one such tool. There's many out there, but I like it because it's very visual. It has a nice input format and it's online, so we can share it pretty easily. So if you go to wolframalpha.com, you can actually type in your question. So one example here is integrate 2 pi r times dr from r equals 0 to r equals r. So that's actually the formal description that we had before, but it can actually take that description and work it out. And if you look at it, the definite integral here, don't worry about the indefinite one, the definite integral is pi r squared. So whoa, this is pretty cool. We didn't have to tell it, okay, take the area of a triangle and go into disks. We just gave it a very generic description, and it popped out a very generic answer. Now, it's up to us to remember that, oh, this is referring to the area of a circle, and that's what the result is. I mean, it doesn't know what it's trying to compute. It was just told that I have these slices, put them together, get the result, and give it back to me. So we're actually able to take this very generic description and have the computer do the work for us. Now, this is pretty powerful. It's like having a very industrious helper who can sort of do all the grunt work once we've sort of set up the question. Now we can go the other way too. If we already know the area of a circle, we can derive it with respect to r and get the size of those slices. So remember, we can go forward and backwards. So if we know the area of a circle, which is pi r squared, and we want to say, well, how big would each strip be if we cut it along the r direction? Well, we say derive pi r squared with respect to r. And lo and behold, we have 2 pi r, which is kind of the size of each one of those strips. So we can sort of work forward and backward with this tool, and it can sort of do the work for us. Now, a little bit lower, we have some examples here where I've taken our visualizations, I've written them as symbols, but I've also written it in the format that Wolfram Alpha can take to compute it. So you can actually click on each of these links, and it'll take you to the Wolfram Alpha calculation to figure it out. Now, one kind of neat thing is that if you look, certain equations seem a little bit easier than others, right? So this one, measuring the area of this guy, well, it's not too bad. This one, measuring these wedges, again, not too bad. But this one, oh, it's kind of tricky. Working out this area is actually a lot more work than these other two. And you might notice that Wolfram Alpha actually takes longer to get this result than the other ones, because the board-by-board analysis is actually more work to reverse engineer in a way than these ones would be. So it shows that our difficulties aren't just theoretical. It's a practical thing where you would probably prefer to use this approach or this one and not this one if you had to do the problem by hand yourself. Now, things like Wolfram Alpha, again, these are kind of like a grammar checker or a spell checker. It helps us practice our writing skills and make sure that we're kind of staying on the right path. So as we go through, we'll be learning the rules of calculus ourselves, but we have these tools which can kind of double check and make sure that we're doing the right thing. So in the future lessons, we'll be using this as sort of a experimental tool to help explore the rules as we work them out ourselves. Happy math.